Okay, welcome back. So we're actually going to get started on making kind of the back end, kind of engine-y side of our game. So today we're going to work on the entity system, and some of the utilities we're going to use throughout our game as well. Since I don't really know what kind of game we're going to making just yet, I'm not sure. I mean, you guys can like comment or something, but I'll probably I don't know. But if you guys want to comment what kind of game we should make, preferably 2D because 3D is a bit advanced for this kind of for the target audience of this series. If you know what I mean. So something 2D and something relatively simple like a platformer, no RPG, not like I mean even like a card game or something is doable. But yeah, so in this video we're going to be looking at our entity system and entities, as well as we're going to be implementing kind of the vector utilities we're going to be using too. So let's get started. So what we're going to do is we're going to make a new class, and this is just we're going to put this under a package called entities. And this class is going to be called entity, of course. And it's going to be an abstract class, and we're going to need the properties of it. So we're also going to need a few more things. I'm going to set up my package representation to hierarchical because that's how I like it. And we're also going to make a new class for our utilities, which is going to be our vector, specifically a vector 2f. And for now, it'll just be a pretty straightforward implementation, which is private float xy, a vector 2f constructor, which take xy, this to x equals x, this to y equals y. And I actually like to make these public just because getters and setters are a bit tedious sometimes. And we also need the getters and setters as well. Could just generate them, but whatever. And we're also going to need a constructor for an empty vector, which is basically nothing. And then we just do, I think it's just this, 0, 0. I think that's how you do it. Yeah, that's how you do it. We can also do one for like a scalar or something. Just like this. I don't know, something like that. That's, I think I've used that before, I can't remember. Anyway, so that's, oh yeah, we need to do our getters and setters as well. So x equals x, and this is our basic, really basic vector. We can also add, later on we'll be adding like cross product and dot product and everything, and normalizing methods and all that stuff, the helper methods already. But for now that should do. So we're going to make these protected, and protected is basically, it basically means that you can only access this method, this property of the class if you're like a child of it, or if you are a, it's like private, but you can access it if you're a child, or you can access it, yeah, I think it's just if you're a child. And this is just going to be the position. We can also cheat and use it for the size as well, but it's not really a valid use of the vector. And then the entity, this is where it's interesting, because we can either initialize the position straight away when we create the entity, or we can just create the entity and specify a position somewhere else. But I think I'm going to just do it straight away. So public entity vector position, this top position. I'm actually going to shorten it to pos because it's just a little easier. There we go. And then we're going to need an image as well, so we'll just say image, and this is the image for the entity, protected image. And we can even say have a constructor which is vector 2f pos, vector 2f size, image, pos equals pos, size equals size, whoops, and then the image equals the image. And then here we can say the image is the image. Actually, no, we don't have to do that. We can do this, pos, and then new vector 2f image.get width. Just set to null. Image.get height, null. And then we do the actual image itself like this. And there we go. Now we need a few. If you remember in our game, we had the init, update, and render. We also need that in our entity, and these are going to be abstract. And you'll understand what that means as well, and they don't need a body, it's a prototype, basically. And we change this to update. And this render is going to be a little bit different, because it's actually going to take graphics G. and the update is also going to take double delta. And we don't actually have that set up for our time thing just yet, but we'll add double delta in the update. And then for now we'll just set this to, no, 1. Doesn't really matter too much because we're not going to use it just yet. And we also need the getters and setters, which are just the getters actually, and I'm just going to generate them. So if you go to source, generate getters and setters, choose select getters, press OK, and now we have it. Okay, nice and simple. So we have our vector2f utility, we have our entity, and we have our game. And I'm going to make a new class, and this is going to be, I don't know, we could do the state system. Let's do the state system as well. So this is where we kind of get into the more, this is all kind of the back-end stuff, which you won't really, it's just to make life easier for you, really. So we're going to make another class, and this is going to be under a state package, and we're just going to call this state. And basically, this is going to be abstract as well. And we're also going to have a state manager class. And this is going to have one state called the current state and the pending state. And I really like this kind of mechanism, or you could say, there's loads of different ways to handle states, but this is my favorite by far. And what we do is we're going to need to take a protected state manager instance, and we're going to need the state manager to be passed through the constructor as well. This.stateManager equals state manager. And then we need the getter and setter for it, so select getters, select getters. And then we also need the, we can copy and paste them from the entity. So like this. And if we press Ctrl-Shift-F, that should format it. So this is basically our state. And the reason why we do this is because this makes it a lot cleaner for our actual states to be switched. So some people use enumeration, which is one way to do it, but it can get really messy because if you have your switch and you have like 20 states, it gets incredibly messy. So switching it up into IOP is a lot cleaner, in my opinion. 10 times as cleaner. So we'll create a new class and we'll call this game state. And this is going to be just a state for the game itself. And you can have other states for like the menu, end game, all that kind of stuff. State for everything. And this needs to extend the state. And we need to add the constructor and then the unimplemented methods. And if you hover over it, it will do it for you. Then we can delete the stubs. And this is our state. And we can test this works because we can render a orange rectangle, for example. I didn't actually show you how to get different custom colors, which I'll do in a second, actually. I'll do it now. Actually, no, I'll do it in a second once this actually works. Don't want to deviate from our original plan. So this is our state, and this is our state manager. And the way the state manager works is basically we have a few methods. So the first one is we request a state, and we pass through a state. And this basically says pending state equals state. So what this does is this says, okay, please dispose the current state, and I want you to put on this new state. But if the current state is doing something, you can let it finish what it's doing. And then we have something called a force. This is what I like to set it up as anyway. A force state, or forced state, which is basically where you don't care, just set the state straight away. So we do current state equals state. And we also, in fact, I didn't set that up. Yeah, let's just not worry about it. Usually when I use OpenGL, I add a dispose, which basically means that when the state is destroyed or disposed or not used, it will call that method, and that will clean up any OpenGL things, but we're not using OpenGL, so we have nothing to clean up really. And this will basically just say current state equals state. And then we have our process state changes, which basically says, this is called every frame, or yeah, every iteration in our game loop. This is what this is called actually. I didn't actually mention, this is called a game loop, typically around the game development community, you could say. And this is called all the time in the game loop after every update, basically. And you basically say if the pending state is not equal to null, so it has something set to it, which we do here, we're going to say current state dispose, but we don't really have to do that. So we're going to say current state equals pending state, current state dot initialize, so we want to call the initialize method, and then pending state equals null. And in the for state, we just do current state dot initialize as well. And even then, we can just say forced state, pending state, and that should clean it up a little bit more. And this is basically all there is to it. It's a little bit of a cleaner workaround. It's kind of redundant in a way because we don't have the disposing, and the idea is this is kind of queued up so that everything's disposed properly. But because we have nothing to dispose, it's kind of redundant, but it doesn't matter too much because it's still a clean way to do it. And in our game class, we're going to create an instance of this state manager. And the idea is that this state manager is passed around the entire source code. And then we initialize it in the init method. So here, we use state manager, and we can just request dot request state, new game state manager, and then we have it. And then we also need to do in the update method, in the game loop, state manager dot request state. No, wait, what? State manager dot process. And then in the render method, we can delete all of the stuff you're rendering except for the black. This is really important you keep this because that's the clear screen. And we do state manager dot what we actually do is, we didn't do the getters and setters. We need the getter and setter for the current and pending state. And I usually like to make a variable called init, which basically says if the current state isn't null, we call init. And we do this for all of the other methods, so update and render. So let's make two more. Change the name from init to update, double delta, remember, render, graphics G, and then we just change this to render and G, and this to update and delta. And there we have it. This should work. Need to import our graphics as well. And this is just a bit more of a safer way, and it's a bit cleaner too. So in here we put state manager dot render G, and this is where we pass through the G object, and we use state manager dot update delta. And then in here we can change this init, here to, although we don't need to worry about that because it will not be null. Cool. We can do like a check, like if state is null, we can say, we can throw an error. So you can say throws something that's a pain in the ass. So I'm just going to say sysr error state given is null, and then we can just return. And this is just if we try and request a null state, it won't work, but that probably won't happen. But just in case it does, it's good to plan for it. So if we run this, we get our orange square because we're in the game state now. So this means that it's a lot cleaner. So instead of writing our code in this class, all of our code for rendering will now be in this class. It's just a way to keep things separate and a bit clean. And we can remove this image initialization because we won't need that. And that's pretty much it for this current episode. Next episode we'll look at the time step stuff. And then we'll probably look at rendering our entities because we haven't set it up just yet. But anyway, thanks for watching. See you next time. Bye bye.